Hi, my name is Neil Joshimpule, and I'm bringing you this presentation on OLAP data modeling for beginners. It'll go over the basic principles and data design techniques used in OLAP data design. Since this is such a broad topic and has so many sections, I'm going to separate this video into two videos, and this will be part one of a two-part series because I can't possibly complete and load all the beginner's knowledge for data modeling in one presentation. Okay, so let's get started. Okay, so I'm going to first start off with a little bit of theory, followed by a simple example, followed by a continuation of the theory. In the next lecture that follows this, I'll give more complex theories and more thorough theories. However, I believe this is enough for you to get a basic comprehension of what OLAP design entails. Okay, so let's start off with this. What is an OLAP? OLAP is short for Online Analytical Processing Database. It's basically a database you use to store historical data from a front-end database. This database is used for generating reports, which is basically an interpretation of the data held within a OLAP database. And this database, like its name entails, Online Analytical Processing Database, is also used for data analysis. It contains historical information. So now, where do OLAPs get their information from? Well, an OLAP is a back-end historical database. So rarely, if ever, does the OLAP, in theory and in practicality, ever get information stored in it directly. Normally, when information is put in OLAP, it is already processed. So an OLAP has its information loaded either directly from an OLTP via extract, transformation, and load principles. So the data from the OLTP is converted into a more historical appropriate format and put in the OLAP. Or sometimes you will have a center database called a staging database, which will process a lot of the database information from the OLTP separately. If you looked at my previous slides, an OLTP is simply a transactional database, a front-end database that deals with all the processing. So staging database is a database that would be made solely to process the information from the OLTP and perform cleaning of the data, verifying that the data is real, and other processes before putting in the historical database. And then sometimes you'll go through four databases before putting in your OLAP. The first one will be your front-end database, or the OLTP. And by OLTP, you don't always have to have just one front-end database. There could be multiple front-end databases. I'll go into different design structures that I have learned of in a following lecture. However, the OLTP could put it in a pre-staging database. The pre-staging database's main purpose is to gather information from different OLTPs. Then from the pre-staging database, you could gather all the information together, move it to a staging database, or you could even merge the pre-staging and the staging database together in certain circumstances. And then what will happen here is that in the staging database, you would perform your cleaning, verification, and statistical analysis of the information before loading, transforming it, and putting it in a more historically appropriate form, and then loading it into the OLAP. The concepts of pre-staging and staging databases are theoretical mostly. You could implement them in various ways, and it is really just a gray box. And the functions associated with them are definitions. some companies may deviate from these definitions because definitions and theoretical versus practical are rarely the same thing. Okay, so now let's go on to the next slide. So as I said, the OLAP gets its information from the front-end databases and the information may be processed and prior to being loaded into the OLAP. Do all systems and database systems have data warehouses? No. So data warehouse was a term coined in 1993, I believe, by Kimball. No, sorry, it was Cod. Cod, the creator of the database, or the original inventor of the theory of databases. But why? Because sometimes you don't have a need to track information. Sometimes people that build databases don't know a lot of the new concepts associated with it. And there are various other reasons why. Sometimes people might go on their own creative edge and do something different. However, for any data warehouse that is worth paying attention to, any company that is growing at a rapid rate, they normally have a data warehouse to keep track of their information and process it so that they could understand the data and use it to their advantage. Knowledge is power, and data warehouses give you access to that knowledge in a comprehensible way. So, analogy to this would be looking at a puzzle. Sometimes you could put, you get all this information from, you have all this information, which is puzzles. So, over time, you're going to have more and more puzzles pieces. What the data warehouse will do will take these puzzle pieces from your front end database and put it together. So now you're going to have separate puzzles with all these different pictures on them, stored in this one area. What a report will do will take the puzzles you want to look at that are already put together in an easy to understand way and present it to you, present only what you need to you so you don't get confused, because seeing too much at once could end up confusing newcomers and people that are not used to seeing things outside of their domain. So by creating a report, which is like a view on some of the data within the data warehouse, you will present to people information in a way that they can understand. I'll get more into reports later on again. Okay, so data warehouse design is often referred to as dimensional modeling, while or dimensional modeling is equal to data warehousing, and data warehouses are the same as OLAPs. Modeling of OLTPs, like I showed in my previous lecture, is considered relational modeling. It's a term often associated with them. What are key concepts of data dimensional modeling? Well, dimensional modeling is based on business processes. It is meant to answer questions about the business. It deals with a much larger amount of data than front-end databases. Another term you might hear is data marts versus data warehouses. Basically, all a data mart is a subset of a data warehouse. So it's only part of a data warehouse, and it doesn't track all the processes tracked by a data warehouse. So a data mart may only track like 3 business processes, while a data warehouse that contains it, the data mart, will track 20. Another term you will often hear is fact tables versus dimensions. Fact tables are the physical database implementation of a business process. So one fact table corresponds to a business process. What is a business process? A business process is basically anything that occurs in your business. For example, a business process would be selling things, or labs, anything that goes on with getting lab data, or another example would be selling productivity, etc. So a business process is the steps involved in these processes. So in order to make a sale, you'd have a person come to a store, they buy something, then they go to a counter, they pay for it. Well, they pick something they want to buy from the store, then they go to a counter, cash register, they buy the product, and then they leave. That is a abstract view of a business process. So a fact table refers to or corresponds to a single business process, and a dimension table basically has the the entities or the things involved in a business process. What do I mean by that? For example, a dimension corresponds to physical things like a buyer, the guy that went to the store in the business process. The store could be another dimension. The product could be another dimension. And anything involved in the business process could be considered a dimension. The fact table is just the business process, and it contains all these different objects which have properties of their own. So while the I'll show you an example to illustrate this. But before I get into the example, why is OLAP design different from OLTP design? So why do they design OLAPs different from OLTPs? It's because the OLAPs serve a different purpose. OLTPs tend to have more delta operations or insert, update, and delete operations performed on them, while the OLAP will have more select queries performed on them. Therefore, the way you design them will impact their speed, and due to the different operations that are more likely to be performed on them. So here's a table I found on the net that describes the differences between OLTP systems and OLAP systems. Firstly, the source of data in an OLTP is the original source of the data. In the OLAP, it's consolidated data. You'll understand this in over time. OLAP comes from various OLTP databases. What is the purpose of the data in an OLTP? Is to control and run fundamental business tasks. So as I said, it tracks transactions directly with the user. And OLAP helps with planning, problem solving, and business decision support. So that's the reason for the reports generated on OLAP systems. OLTPs reveal a snapshot of ongoing business processes. So it's only a subset of the data. It changes over time, while so it doesn't contain all the information at a part. It only contains information for a particular moment. While OLAP contains a multi-dimensional view of the data, so it could track data over time and has multiple snapshots of the data at different time periods, and tracks different business processes based on the front-end database. OLTP needs to be able to perform short and fast inserts and updates, while an OLAP has to be able to handle massive data loads and lots of reads performed on it. The OLTPs have simple queries performed on them, while the OLAPs often include very complex queries in order to generate the reports. OLTPs are fast. OLAPs depend on how much data there is in it, and queries can take hours. And oftentimes with the OLAP, you had to create indexes in order to improve their performance and the read speeds. Space requirements, they can be small if historical data is archived in a OLAP. So, however, OLAPs, since they contain the archived data and aggregations, etc., and historical data, they tend to be massively large and need more indexes than OLTP. OLTPs are normalized, while the OLAPs are denormalized and have fewer tables than an OLTP. OLTPs are also backed up a lot. Data loss here is often equivalent to lots of money being lost. With OLAPs, they're not as concerned with the data, since it's important, but since it's just analyzed and isn't used by the customer real time, it isn't backed up as often. However, it is backed up, and loss of records on either side could hurt a company a lot, although the OLTP tends to have more, keep more important information within it. All APs tend to be very large, so backing up the system is very space and time consuming. Okay, so let me get into an example, because the way I see it, examples are the best way to get an understanding of what a concept really entails. So for this example, I'm going to do an example OLAP data mart design. So this is a subset of data warehouse, because it's only going to answer one or track one business process. And I'm going to use Kimball Snowflake approach when doing this. So now you have the roles in design. In any data warehouse design, you're going to have someone that does data analysis and make sure that the data coming into the data warehouse is good. You'll have a business analyst that will make sure that the data mart and data warehouse answers the questions that the customers or the end users need answered, because a lot of times the customers and end users will only know what they want from their business. However, they won't know everything they want. So they'll talk to a business analyst that has a lot of experience. What the business analyst will do is talk to the customers, get a deeper comprehension of what is going on, and reason with the end users, and find out the big picture, and find all the processes in the business that need to be tracked. And at times the customer might not realize everything they want to be tracked either. So talking to someone with more experience tends to help them clarify their requirements. So this is the duty of the business analyst, and he acts as a medium when talking with the other people on the team, like the data modeler, the person that actually designs the schema of a data warehouse, so that it'll remain fast, the developers who implement schemas and the ETL, and the quality assurance team who make sure that the system works seamlessly. Okay, so here's some abstract concepts. I'm going to show you an example in a second, but I want you to know what this is, because I might have mentioned it before, but not explained it properly. So a fact table corresponds to a business process that the data mart will track. Each business process has one fact table. What is a business process? Once again, a business process is anything in your company that your company does that you want to track so that it will give you money. Because the end purpose of a data warehouse and data marts is to obtain useful information that you can interpret, that will consequently provide you with a means to make money by knowing it. So that is the purpose of making fact tables with business processes. It all comes down to money. So what dimensions do we need? Dimensions are tables that contain information about the different attribute properties of a business process being tracked. So basically, dimensions go hand in hand with fact tables. A fact table cannot exist without having a dimension, because otherwise you're not tracking anything and the fact table will not have any useful information. Because you're so basically, within a fact table, you're going to have different, or within a business process, actually, you're going to have different subjects involved, as I will show on the next page. These subjects will be like people, stores, products, etc. However, when you're identifying these different objects that are involved within a business process, that you're going to contain information about, you have to make sure that the different departments that will be looking at this information agree on the definitions. Because while it might seem easy to come up with a business process and define the different elements of it involved in it, sometimes people's slightly different misunderstandings of the concept might make it so that they'll expect a business process to work one way, and another department will understand it to work a different way. And then when you create a data mart that doesn't have a streamlined understanding of how everyone thinks that this business process works, it might not be suitable for answering all the questions that the end users think it should answer. And then that will be all fall on you, and the people get pissed off, and you don't want to do that. So you got to make sure people know what they're talking about, and you clarify the definitions, because by clarifying definitions, you'll have less room for misunderstanding from the different people later on. So you have to make sure they know what they're talking about before going forward with this design, because a lot of times people think they know what they're talking about, but they don't. Okay, so what am I going to track? So let's start off this design process. So before we even start designing a data mart, as I said, we're going to pick a data mart that we want to, or identify a business process we want to track to create a data mart out of it. We had to ask ourselves, or what we're going to track. And this would be a question the business analyst would ask himself ask the customer after examining the requirements written down by the customers and end users, and he would talk to them about it. And so the business analyst would be like, okay, I read your requirements and what your business requirements are and what you think you need. So now let's solidify this into a business document, which the business analyst would write, and see if we're on the same page. So right now we're going to track product sales. I'm giving you an abstract. This is a business data mart made for a store. So basically the business analyst would sit down with the customer and say this. Okay, so this is everything that goes into buying a product from your store. Firstly, we have a buyer that goes to a particular store. He chooses a product from an aisle. Then he goes to a counter with a particular receptionist. He pays with credit card, cash, or whatever. He leaves the store, and he'll either keep that product or return it. That's the process that goes into buying a product. In fact, you could probably even make returns a separate business process. I just threw that in. This is an abstract beginner's level presentation that I made on the fly. However, you normally make returns a different data mart. So we're tracking this process in product sales, right? So basically, if you look at the bolded letters, I'm identifying dimensions. What is a dimension? Once again, it includes any objects that are part of a business process. So these are the actual entities or physical things that are involved within a business process. So we have buyers, which are people that go and buy products. We have a store, which has its own properties like location, country, name, etc. The buyer would have its own properties like name, demographic, race, um, uh, income, etc. A product would have its own properties um, like uh, cost, name, brand, uh, size, etc. Even an aisle could be considered a dimension if you wanted it to be. An aisle could have its own properties like location. Um, Going even deeper into that, rather than aisle, we could even within the aisle that the product was listed, we could look at the shelf it was on, the position in shelf it was on, the side of the aisle it was on, the lighting. There's so many things that you could track within a business process if you wanted to. Um, so so aisle could actually be product location within the store. Then a counter would have its own properties. For example, it could be located at the front or the back of the store. It could have it could be electronic, or it could have a receptionist. It could there are various other properties that a counter could have. A receptionist, the person that processes your order, could be a man or a woman. Um, could have certain work hours, etc. Um, Payments will have their own properties when making a sale. It could be by cash, credit card, etc. Um, and that is the business process. So now let's make a data mart out of that. And I'll explain to you how it works after showing you the data mart. So here's the data mart. Although I haven't put in all the dimensions, um, or that were involved, I have included two of them that were identified in the previous page. So the business process we're tracking, this is our fact table, the sales fact table. With fact tables have properties called measures. They're numeric or ratios or percentages, always. They're used to track trends in the business processes. So, for example, if you wanted to track the relationship between uh, a counter and a product, how many are sold, like from which so when you sell at a particular counter, how many products are sold, you could include that as a measure. Of course, you don't have to keep it over there, but it's just this quick example. And then we have our buyers and our counters. These are definitions all departments have agreed on, and they have properties. As I said, like a buyer could have its um, demographic, physical attributes, etc. Over here, I left empty dimensions. These are entailing the other dimensions I mentioned on the previous page, like product, receptionist, payment, anything in the bold. So this is the Snowflake schema, and a property of the Snowflake schema is that the fact table is always directly connected to the dimension. And since we're tracking a particular business process in the dimension, we could join between the table, the fact table and another table in order to derive more detailed information or more detailed questions about that particular um, business process. So basically by having all the entities there, we could come up with questions. We could um, based on the business process data marts that exist, and we could derive useful information out of it. So maybe we want to know um, how often a particular buyer but goes to the store and buys from a particular counter over time. So we could have a time dimension, which is actually a very important dimension that's used in most all data marts. That makes sense, right? So you could use joins to derive information from that, and by joining with the time dimension, the counter dimension, the buyer dimension, the sales fact table, the fact table basically will have foreign key references to the different tables and how they're related. By joining between all three of these tables, you'll be able to, in different ways, or you'll be able to answer the questions you want or get to the information you want out of it. So as long as the business process is tracked, you'll be able to derive all sorts of useful data from it. It's just a matter, once you got a proper data warehouse in place, the next step is to think of the most useful questions you can ask that data warehouse. And by asking those questions, you will get the answers you want. And answers are power. So with all that information, just finding it comes down to just knowing the questions to ask in order to know what you want to know, which is a powerful property. Okay, so let me get back to some more theory. So what is the difference between fact tables and dimension tables? Once again, fact tables don't have any data about the business processes they track. They only contain statistics like totals, quantities, discounts. These are numeric quantities that are either ratios, percentages, and amounts. So measures are contained in fact tables. Dimension tables contain attributes like name, category, price. This is because dimensions are actually property based. Another example is a time dimension that I showed it over here, and it has different attributes like order date, year, quarter, month. The customer dimension, name has name, address, city, zip code. Employee dimension has a name, supervisor, department, region, territory. Okay, so now with dimensional modeling design methodologies, there are two main methodologies. This is the Kimball star methodology and Inman Snowflake methodology. The example I showed before, which was a simple abstract example, used the Kimball star methodology. Basically, the star methodology makes sure that the fact table has at most one join with the dimension tables it's related to. The Inman's Snowflake methodology could have the dimensions don't have to be directly connected to the fact table, while the fact table does have to be connected to another dimension. Dimensions could be connected to other dimensions. What does this mean? What this means is that Kimball star methodology, since it contains direct joins or relations to the dimensions, tends to perform faster than Inman Snowflake methodology, which is connected to dimensions indirectly. So while Inman Snowflake methodology could result in smaller data warehouses, Kimball star methodology will perform faster. So here are some dimensional modeling examples. On the left, we have a snowflake model, the blue over here. The blue box over here is actually a fact table, and the gray boxes on to the left and the right of it are dimension models. As you can see, this dimension is connected to this dimension. The scar schema has direct joins. So for example, we have ship orders, which is a business process being tracked. And it has different dimensions like geography, customer, product, time, and original unit. Another term you might often hear is the bus schema. Basically what the bus schema is a bunch of business processes that share common dimensions. So what they do is, rather than having the dimensions repeat and having separate tables for each business process, they'll combine them into one. One example is the business process ship from manufacturing and retail sales. So ship from manufacturing has a common dimension with retail sales called product. So rather than referring to two different product dimensions, they merged it into one and they both refer to that table. Okay, so now let's go to bus matrices. Bus matrix, you might hear this term also. A bus matrix is basically a method for creating bus schemas. Bus schemas are basically evolution of the Snowflake model. And it's basically a spreadsheet or Excel sheet to see which business processes share particular dimensions. So by doing this, you will combine the dimensions and not having repeating dimensions, and you will share them amongst each other. Another term you might hear is a corporate information factory. What this is basically everything encompassing the data warehouse, including the tools used to process the information from the data warehouses, the operational data stores, which are basically smaller versions of data warehouses that only contain some of the information of data warehouses, and other tools that are involved with dealing with the data warehouse. So anything that is directly involved with the data warehouse is incorporated into the corporate information factory, which is basically an information factory. So data warehouses contain information, they process that information, and they give it to you in a form that you can understand. So definition is equivalent to what you think it is. It's pretty self-explanatory. It's a information repository that processes information and presents it to you. Okay, so now as we get further into dimensional modeling, you'll hear terms mentioned like conform dimensions, junk dimensions, role-playing dimensions, degenerated dimensions, and slowly changing dimensions. What are these? Well, a conformed dimension is basically a dimension that is shared by two or more fact tables. So as I showed you before with the bus schema, and the utilizing of a single dimension by more than one fact table, that would be considered a conformed dimension. A junk dimension I'll get back to afterwards. However, a role-playing dimension is a dimension that has been merged with other similar dimensions. So for example, I mentioned previously time dimension. The time dimension could be merging of different time dimensions, like for example, you could have order time and you could have a dimension for that. You could have receiving time and you can have a separate dimension for that. You can have processing time and have a separate dimension for that. Or you can merge all three dimensions into a single dimension called the time dimension, and so so these different time dimensions will become one. And since this dimension serves the purpose of more than one role, since it could serve the purpose as either order time, purchase time, or processing time. It is considered a role-playing dimension. Role-playing dimensions are not just exclusive to the time dimension. You could use it with different things like employees and buyers. Since they have a lot of the similar properties, you can merge them into one dimension and just refer to the different rows by a foreign key reference. And since it serves the purpose of two dimensions and you merge them for simplicity, this means that you will be able to have or refer to it in it's a role-playing dimension. It serves the purpose of more than one dimension. Slowly changing dimensions are basically dimensions that have time flags and keep track of any changes to particular items in that come in from the front-end database. I'll explain that later. And what is a junk dimension? Basically, a junk dimension is when you have these small dimensions that really have you have these attributes that you need to keep track of, right? And the attributes don't fall into any of the entities. They won't be a part of any of the dimensions that already exist in your table, but you want to have these values there. So sometimes what people do is create a junk dimension, and that'll contain the information that you need, but doesn't really fall into any of the categories. I remember once upon a time I was working with a lab data system, and they created codes dimension. The codes dimensions basically had information about that was general information that didn't fall into any particular area, but they needed. So a junk dimension is basically a dimension that is a general dimension for attributes that can't be contained by any of the other dimensions. And another term you might often hear is degenerated dimensions. What a degenerated dimension is a dimension that has its attributes shared and contained within other dimensions. So by only having a foreign key reference to it within the actual fact table and referring from the fact table to these other dimensions, you can get rid of the dimension completely. So it degenerates. So basically what a degenerated dimension is a dimension that is held within a fact table, because it doesn't need to exist since its properties are redundant. So you get rid of the dimension and you just refer to its attributes which are contained within other dimensions from your fact table. Okay, so now let's get to slowly changing dimensions. As I said before, a slowly changing dimension is basically a dimension that keeps track of changes made to data. There are three types. The first type has a column that is dedicated to keeping track of whenever that particular row has been changed. It doesn't have any history and only has that row at a particular time. A type 2 slowly changing dimension has the change date and the update date in separate columns in that table, and it keeps track of any changes made to a particular record or row over time. and it has unlimited history. And then we have type 3 slowly changing dimensions, which is basically the same as type 2. However, at any particular time, it will only have a certain amount of history contained within it. So it might only go back, let's say, 2 changes, or it will not keep track of all changes that are made. It will only keep track of changes to a particular point. So that might be that the slowly changing dimension has records and changed records for up to 3 changes or 5 changes, or normally I believe it is about 2 or 3 changes, and the higher type you go after that is a variation on the changes. So type 2 and type 3 will have 2 additional columns, which is the change date, the initial load date, and the change date. So slowly changing dimensions are used to keep track of this information. In the next presentation, I'm just going to give a lot of examples to help clarify these concepts. Okay, so now here are some special situations that I'm going to talk about that you might want to read up on. I'm only going to go through it generally, since this lecture has gone on for quite some time. However, a lot of times people will talk about speeding up the loading time in data warehouses. There's an ETL technique that is used to reduce the data loaded, and it's called incremental load. Basically, what this does is keep track of the changed records in the OLTP and the records that exist in the OLAP, and it only loads the changed data. I'll have a separate lecture for this. This is an important concept, and it decreases network load. There's also, you'll often hear a term called real-time data warehouses. Basically, what this means is that whenever a change is made in the front-end database, it'll automatically be made in the data warehouse. So the changes are instantaneous. It has a lot of load, but it frequently, when you're analyzing data in the data warehouse, you know it's always up to date. You have operational data stores. Since the data warehouse is often quite big, and slow to process the information within it and read through all the information within it, they make a smaller version of the data warehouse that only contains information for a certain time period. Therefore, since it's accessed, this smaller version of the data warehouse has analysis done on the data quite frequently, and since it's done on it quite frequently and it's smaller, you could do analysis on it more quickly. So you'll be able to generate reports based on the ODS at a faster rate than if you were to generate the same reports on the data warehouse using the information from the time that goes back to Lord knows when. So an operational data source would contain data for, let's say, the last month or the last 2 months. It's a smaller time period than the data warehouse. You could take it further, and the operational data source could only contain information for particular processes that you know that are going to be analyzed. So maybe you don't need to have the entire data warehouse processed. You only need particular business processes from that, so you don't have to contain all so for that particular time period, you don't have to contain all the data warehouse's information for it. You can only contain a subset of the information and the business processes. So that'll cause a further speed up since it's smaller. And often you're going to have late arriving dimensions. When information is taken from the OLTP to the OLAP, what usually happens is that the dimensions are loaded before the fact table, just because of the logical foreign key primary key relationships. But sometimes the dimensions won't arrive on time. So between a load, you're not going to have all the actual, you might get the fact table record, but for some reason on the actual OLTP side, the dimension data wasn't completely completed. So basically there are techniques used to handle this. It's a more of a complex situation, and certain terms you'll hear used are ghost tables and dummy rows. These are 2 different techniques used to handle this particular situation. I suggest you go and read up on it on your own. I might mention it in the next lecture. However, I'm going to just mention this for now since it's going to take, I want to wrap up this lecture. And I guess that is all for part 1 of this series, and I hope it helped you. And that is all for now. Thank you.